Hello, everybody. Welcome to the OpenTimelineIO portion of this year's Open Source Days, hosted by the Academy Software Foundation. And we're going to start off with a video. All right, welcome everybody. So I'm Joshua Miner. I'm the chairperson for the OpenTimelineIO steering committee. And today we are going to talk about a bunch of different things. First, we're going to have an overview of what is OpenTimelineIO. Then we're going to have a status update, talk about project goals, and then we have three separate groups of guest presenters who are going to talk about projects that they're doing with OpenTimelineIO. So buckle up and let's get going. Let's start with an overview of what OpenTimelineIO is, for those who are not familiar with it. OpenTimelineIO is an open source project with three main parts: a file format for storing editorial timelines, an API for software engineers to use when building tools that work with these timelines, and adapter plugins for converting to and from OTIO and other file formats. In practice, timelines often contain many tracks, thousands of clips, and can represent years of creative filmmaking decisions. This image shows about 20 minutes of the editorial timeline from Toy Story 4. OTIO is designed to help you work with this type of timeline. OTIO's file format and API have a unified data model with concepts like tracks, clips, transitions, markers, and so forth. Most of the things you might see in an audio or video editing application can be represented in OTIO. However, the OTIO file does not contain the actual media itself. Instead, it uses media reference URLs, which point to the audio and video media in any format or location. OTIO includes adapters, which can convert to and from a wide variety of other formats. Since adapters are plugins, the system can be extended to support common formats in use in the industry, as well as custom playlist formats in your own workflow. By converting to and from existing formats, we can interoperate with many applications today, but as you will see later in this presentation, we are shifting towards more native support for OTIO to improve interchange. OpenTimelineIO also includes a utility application for viewing the structure of a timeline. This is meant for developers when debugging or learning how the system works. You can see here one of the key features of OTIO, which is the ability for any OTIO object to hold extensible metadata. The clip I've highlighted in green on the left is shown in JSON form on the right. Near the top, you can see a dictionary of metadata, including some custom production tracking information. You can add your own metadata here side by side with others to support whatever workflow you need. OTIO's core is written in C++ and includes language bindings for Python, Swift, C, and Java. This means that the same functionality is supported by all of those languages, and developers can use the language that best suits their own application. OTIO adapters are written in Python, which means that non-Python applications will use the external OTIO convert utility for file format conversion. And with that, I'd like to hand it off to Stephan.
Hi everyone, I'm Stephan Steinbach, and I'm on the OpenTimelineIO Technical Steering Committee. I'm going to give some updates on what has been going on with OpenTimelineIO in the last year. I'll talk about some ongoing projects first, then talk about some of the language bindings that have launched, before talking about some ongoing conversations in the community and plans we have for how to manage the main OTIO repository. The first project I want to highlight is centered around the build system. Last year, we released our first build of OTIO with a C++ core. This is super useful, but it significantly complicates the build process, especially for users who just want to type pip install OpenTimelineIO. Thanks to feedback and contributions from the community, we have a much more robust build system for the C++ portion of the codebase than last year. For Python users, we can now build wheels and are working on the last step, making the CI system automatically build and then publish wheels, which would dramatically streamline our release process. And again, thanks to community support, we are even able to build wheels for Windows. In particular, we want to call out contributions from Jean-Christophe Morin and Roger Nelson. Another exciting project is one to build a native integration of OTIO in RV. This would mean that you could directly read and write OTIO files without the use of an adapter in RV. This simplifies the pipeline for getting your editorial data into and out of the application and removes the need to convert to an RV session file first. Autodesk is also leading a project to build a 2D spatial coordinates representation for OTIO for modeling bounds and placement within an image plane. They're building on top of iMath from another Academy Software Foundation project, OpenEXR. We've also been working on making the C++ library itself easier to use. That includes bringing more of the algorithms over into C++ and general quality of life improvements for how the API works. Thanks to Darby Johnston, who will be presenting later on for that work. Karthik Iyer also contributed a cool SVG renderer for OTIO timelines, which lets you render the structure of a timeline to an SVG file. Great for documentation or other uses where you want to save a snapshot of what the visual structure of a timeline is. Next up, I'm going to talk about some of the new language bindings that have been released for OTIO. In the main OpenTimeineIO repository, we provide a C++ core library and Python bindings for that library. The community over the past year has released and enhanced bindings for C, Swift, and Java. Those are hosted in separate repositories. These language binding projects feature unit test CI and use the Dependabot feature of GitHub to stay up to date with the main repository. There has been community interest in more bindings in the future, including JavaScript, Rust, and Zig. If any of those sound like appealing projects, please get involved. There are a number of more general ongoing conversations in the community that we are a part of. Time-sampled metadata has come up quite a bit over the past year. We've also talked with some folks interested in canonicalizing review metadata, as well as folks interested in titling. Finally, we've been planning how to structure the OTIO repository to align better with the long-term goals of the project. We would like the main OTIO repository to be the home of the C++ core and the Python bindings. Language bindings for other languages have been split out into consistently named repositories. Future bindings repositories should also include regression tests and CI. We'd like to split the contrib adapters out of the core repository as well eventually to help signal that those are community supported and not part of the core library. Nick is going to talk more about the direction we're going in general with regards to adapters in the next segment of this talk. We'd also like to more formally break out the renderers like the SVG renderer or OTIO view to make them easier to find. Finally, there are the various community projects that are built on top of OTIO. Those exist out in the software ecosystem, but are separate from the main OTIO project. Now I'm going to hand off to Nick Porcino.
Hi, I'm Nick Porcino, a member of the OpenTimelineIO Technical Steering Committee. I'm here to talk about OpenTimelineIO as a file format. The OpenTimelineIO project was originally started as a data schema and file format describing editorial data, and as a set of adapters written in Python that worked to convert legacy EDL formats and NLE-specific file formats to the OTIO data schema and file format. Here's an example of a current pipeline workflow. We start on the left in Avid, where we save our editorial composition in the AAF file format. An AAF adapter exists, so the OTIO convert tool uses it to parse and interpret the AAF data and metadata into the OTIO data schema, and then save that OTIO conformed data out as a new file. This new file can participate in the pipeline in any number of ways, but in this case, we're going to use OTIO to convert it again, using the RV adapter to a .rv file, which we'll then use to view our composition in RV. The implementation effort has shifted from the Python adapters to language bindings for native integration. An example of that is work in progress right now at Autodesk on adding support into RV. As you can see, a step is eliminated. After conversion of our composition to OpenTimelineIO, we have smooth sailing into downstream apps reading OTIO natively. We can imagine then that the next step in OTIO's growth and development, a step with less friction, is native OTIO reading and writing from a variety of viewers, NLEs, and other tools. Adapters have driven OpenTimelineIO adoption and have helped to rapidly mature the data schemas. They're not ideal though. They're built with the help of the community, which is awesome, but we are limited in what we can accomplish. In a way, we make them up as we go along. As new wrinkles and formats are discovered, we adapt. And if file formats change our version, we need to go back and work out how to adapt the adapters to keep up as best as we can. Our adapters are versatile, and as the name says, we can use them like universal plumbing fittings to put pipelines together and bridge processes that were impossible or excessively cumbersome to implement. But more steps in a pipeline is more points of failure. More steps, more dependencies, and more bookkeeping to track files and versions. Each step introduces possible data loss. If an adapter wasn't able to process some of the information or metadata, or if one of the conversions went through a format that can't even carry that extra data. Finally, active involvement and diligence is required of the community to sniff out version changes, regressions, and ultimately create the fixes. Native integration, on the other hand, is built by domain experts. When an application is iterated, the native support for OTIO can also be iterated, so there's never signal lag or hysteresis between what an NLE or viewer can do and the ability of OpenTimelineIO to transport that information accurately. Integrations we can tell you about today include these viewers: RV, DJV, and the TLRender library that can render timelines and compositions to OpenGL and Qt. Moving past adapters to native integration requires two things really: vendor support and participation, and this community to ask for that support and participation. Moving forward, native integration will unlock a number of features that are currently desired: specific bits of NLE native data, subtitling information, effects library, and so on. We're closing in on the version 1 specification and release, and we've got our eyes set on some exciting future developments. With that, I'd like to hand it over to our first guest speaker, Darby Johnston.
The OTIO OpenContent Examples are a collection of example OpenTimelineIO files with production quality source footage. They are useful for testing OpenTimelineIO based applications, especially viewers and playback applications. The source footage consists of a number of different formats, frame rates, and resolutions, including movie files, image sequences, high frame rates, high resolutions, and high dynamic range. The footage is provided by Netflix under the Creative Commons Attribution 4.0 International Public License. For more information, please visit their website at opencontent.netflix.com. The example OTIO files are hosted on GitHub, and the source footage is hosted on Amazon Web Services and can be downloaded directly with a web browser or with the AWS command line interface. Links to the footage and directions for downloading are provided on the GitHub site. Soul Avant is an animated short with 72 clips at 24 frames per second. There are two different source footages available for this short. The first is a ProRes movie file, and the second is a 16-bit TIFF file sequence. Sparks is a live-action short with 39 clips at 59.94 frames per second. There are two different source footages available. The first is a 16-bit float EXR sequence, and the second is a 16-bit TIFF sequence. Meridian is a live-action short, the longest of all of the shorts at about 12 minutes, with 83 clips at 59.94 frames per second, and source footage is an H.264 movie file. El Fuente is also a live-action short, with 5 clips at 60 frames per second. Source footage are raw YUV movie files. Please check out the GitHub site and follow WinStar if interested. Also, this presentation is created with OpenTimelineIO and rendered to movie file with TLRender. Special thanks to Netflix for making the source footage publicly available.
Thanks, Darby. I just wanted to interject one thing here, which is there's another ASWF project that's creating sort of an asset library, and we hope that the examples that Darby helped put together from Netflix can make their way into that library at some point, as well as more complicated ones. So we're hoping in the end run to have more of like a sort of a feature film or a full sort of rich timeline with all the sort of lots of tracks and stuff in there as well. So look forward to that in the future. And if you want to know more about the ASWF Assets project, you can take a look at the link here. And next we're going to have Darby speak again about his TLRender project.
TLRender, or Timeline Render, is an early-stage project for rendering editorial timelines. The project includes libraries for rendering timelines with OpenGL and Qt, and example applications showing the usage of the libraries. The project is written in C++ and uses OpenTimelineIO for reading timelines. FFmpeg and other open-source libraries are used for movie and image I/O. The TLRender code is provided under a BSD-style open-source license. This screen recording shows TLRender generating thumbnails from an OTIO file. Currently supported are movie clips, image sequences, and color management with OpenColorIO. In progress are transitions and rendering to files, and to do are effects, audio support, hardware movie decoding, nested timelines, and Python bindings. TLRender consists of a number of different libraries, which include TLR Core, which is the core library for providing timeline functionality, file I/O, and other utilities. TLRGL, which is for rendering timelines using OpenGL, and TLRQT, which provides Qt widgets and objects for working with timelines. The application interacts with the timeline player through playback controls, which are translated into frame requests and are forwarded to the underlying timeline and I/O plugins. The I/O plugins read images from the movie files and image sequences and return those to the timeline and timeline player. The timeline player caches those within memory and returns them to the application for display. Both the timeline player, timeline, and I/O plugins are multi-threaded. This C++ code is a simple Qt-based example for opening a timeline and playing it back in a window. We first include the TLRender header files, the Qt application header file, and the C++ IOStream header file for printing to the console. Inside of the main function, we check the command line to make sure there's a single argument, which is the timeline to be read, and instantiate the Qt application. We then create the TLRender context and timeline player. We then create the timeline viewport, setting the timeline player on the viewport and showing it. We then start the playback of the timeline and start the application execution. Other examples include TLR play-glfw, which is a glfw-based application for playing back timelines. Also, TLR play-qwidget, which is a Qt qwidget-based application for playing back timelines. And TLR-bake-glfw, which is a glfw-based command line application that can read in a timeline and convert it to a movie file or image file sequence. Check out the GitHub site, and if interested, follow and star, and of course contributions are also always welcome. This presentation was created with OpenTimelineIO and rendered to a movie file with TLRender. The sole Levant footage is courtesy of the Netflix OpenContent Project.
All right, thanks, Darby. That was really, really cool to see. And it's nice to have OTIO being used to actually edit a video. Let's see, next we have Nigel and Niall from the Foundry, who are going to talk about a project where they're using OpenTimelineIO.
Hi there, I'm Niall Redmond, lead research engineer with Foundry. For those of you who don't know, Foundry is a software development company specializing in tools for design in media and post-production. So within the research team, we've been looking at a long-standing problem within the media production pipeline and how OTIO can help us solve it. So here's a very simple diagram of the production pipeline, and kind of on the left side, it's all about pre-production and production, and there's a lot of creative decisions with very few technical restrictions. And as it moves to the right, it becomes more technical, less creative, and the data should get passed along the pipeline. However, in the middle here, on set, when the director says cut, there's a gap, there's a distinct piece missing, where lots of data actually gets lost. It depends very much on the production, but frequently the only data that persists to post is camera footage. Even in instances where some of that data is recorded, it can be unstructured and difficult to sift through. And this means that then in post-production, it can be necessary to recreate this required data, often from scratch, which is a huge amount of time and effort. So the problem I've described is particularly magnified in virtual production, when so many of the assets have already been created and the volume of data generated on set is huge. Data that might want to be captured in virtual production sets include data about the camera itself. Lens data is particularly valuable. Camera tracking data, any available DMX data for control of the wall, and potentially mocap data in the mix too. So all this data for virtual production means the gap I've talked about in the pipeline becomes even more significant. And it also means potential fixes are more valuable. And what we're trying to do is bridge this gap, persist this previously lost data to post, and save unnecessary headaches. We've recently been looking at practical ways to capture all this on-set data, to hoover up everything that might be valuable down the line. And if we are able to access that data, the next question becomes how to structure the data capture. And this is where OTIO comes in. OTIO is clearly the perfect candidate for this. Its flexibility means we can capture all the different time sample data types we want and store them in a clean and interchange-friendly format. So this means that after a day on set, along with video and audio, there's a self-contained OTIO metadata package ready to pass off, possibly to an application like Nuke Studio or Hero, where we could conform that data and visualize it on the timeline. And this is what we're calling the timeline of truth, where you would have everything you would want to know about the decisions that were made for a particular take or time code right at your fingertips. So this is a very, very quick look at what this might look like in OTIO. This is a simple little snippet of a capture from some lens metadata from an anamorphic Cook lens we were testing with, just for a couple of frames. You may notice we're not actually segmenting the UDP packet into the correct data structure here. We're just capturing the raw data string and then leaving it for the application to interpret. And finally, this is a mock-up of how a file like that could be interpreted in Hero, which is our timeline product. So we can see here, rather than just having video and audio on our timeline at the bottom, as we normally would, we also have tracks for all that data that we grabbed on set: camera, lens, DMX, and tracking. We could then dig into those metadata tracks and see exactly what was happening at any given point in time. So for example, we have the lens data in the bottom left, where we can see exactly what was going on for a given time code, which lens we were using, the focus distance, aperture, and anything else that was captured. And we could then visualize some of these values if we wanted, like the focus distance over time on the curve editor here on the left. We believe this capturing all the potentially lost data so that it's not lost when the director says cut and passing it down the pipeline to post could be really valuable in review or comp. And OTIO is the perfect tool to help us do that. That's it for me, and thanks a million for listening.
All right, thanks Niall, and thanks Nigel for helping to organize that. It's really good to see folks using OTIO and to pass metadata through a long portion of pipeline like that. And it's nice to see the flexibility of the metadata, allowing you to kind of put whatever you want in there to try things out. Hopefully in the future we can work on formalizing some of that into schema so that it can be more portable in the future. But this is a great start. And I think there are other folks sort of experimenting with very similar stuff. Let's see, next we have our guest presenters from Netflix. who are going to talk about a cool project that they're doing. So take it away, Eric and Kylee.
Hi, everyone. I'm Kylee Pena. I'm the manager for the Creative Technologies Program Management team. At Netflix, we've been integrating OpenTimelineIO into our services, and we've been able to use it in really interesting ways. In fact, OpenTimelineIO is a workhorse powering encoding and interchange workflows under the hood at Netflix every single day. But today, we're talking about an experiment we tried on Hackday. We've been thinking a lot about how OTIO can help us level up, and we wanted to tinker more with something that had a tangible outcome, so you can see the real power of OTIO. For those that aren't familiar, a hack day at Netflix is a 2-day optional sprint where we can put everything aside and focus on an idea that we might not have time to prioritize otherwise. We bring it to life in this short time, culminating in demos presented in a lightning round format where each hack is given 2 minutes to present their work. It's one of the ways at Netflix that we embrace curiosity and collaborative innovation. We couldn't have done this hack alone. At the end of our 48 hours together, our team of stunning colleagues across the country took a quick shot with all of our various cats. It was amazing to see all these people who normally don't really get to work together that often bring together unique expertise to make this hack better and better. Now, fair warning, there might be some Stranger Things Season 3 spoilers ahead, so if you haven't watched it, pause and get caught up. So the idea behind our hack was inspired by one of my close friends who was diagnosed with ADHD in adulthood. She told me sometimes she gets distracted with other thoughts or activities, and she wishes she had some scene descriptions to help her remember the last thing that she actually absorbed. The idea resonated with a lot of people with children, with memory issues, those who promise themselves just one more episode and then always fall asleep in front of the TV at some point. OTIO was an enabler for our crazy idea. The data connectedness at Netflix creates an opportunity for a through line from creative process to the consumer experience. The end-to-end experience is something that isn't leveraged nearly enough, and it opens up so many possibilities. We knew we wanted to be able to put descriptions on the scenes, but how do we get to this end product? Well, it turns out there's a lot of useful data generated during production, and it's just stored away at Wrap. We collect all this data, like this continuity and one-liners for set, chronos. I knew this data existed in a fairly standardized format for my time in dailies, and it's an excellent source for scene descriptions. But how can we connect this to show members the right thing when they pause? Eric is going to show you how we did it.
Hi, I'm Eric Reinecke. I serve on the OpenTimelineIO Technical Steering Committee, and I work in video engineering at Netflix. Foundational to the transparency of Netflix, we have access to not only the production documents with the description, but also a Media Composer AAF the editors delivered when finishing. How can we use the AAFs to place the continuity descriptions in time? Something that stays consistent from script all the way to the screen are scene numbers. We use these numbers to go one step further to connect from post to our members. You can see here the continuity alongside the final editorial delivery AAF loaded into OTIO view. Note that the continuity uses scene numbers and the EDL has a slate number. From that slate number, we were able to derive metadata about the clip, including the scene number. Using OpenTimelineIO's capacity for arbitrary metadata, we just stored the extra info right on the clip there. Now that we have the scene information for each clip, we can build a new data track where we can combine the contiguous clips for the same scene and add description metadata to that scene. With this, for any given time in the show, we can find the current and previous descriptions. For efficiency at playback time, however, we want to go from a fully expressive timeline to a format that's optimized for our player. You can see an example of it here in the window to the left. To do this, we built an OpenTimelineIO output adapter that exports the metadata track as a JSON format optimized for the player. This took under 50 lines of Python code to write. And voila! Thanks to Matthew and Artem's work on the player, this previously dead-end data shows its potential to help members jump back into the stories they love. You can find out more about our Hackday by checking out the Hackday 2021 post on the Netflix text blog.
And this came together really quickly in our Hackday project. Again, just 48 hours. We brought together domain experts across the company remotely, and we were enabled to do something novel with the Netflix platform, thanks to the open collaboration, transparency of information, and the availability of OTIO. Now, there are a lot of useful, utilitarian, or interesting use cases for OTIO, but even more interesting is using OTIO as OTIO instead of just as a little piece of a pipeline. We want to see broader adoption and exploration of OTIO, and we decided to share this proof of concept we built to inspire even more creative problem solving and thinking on a bigger scale for what can be done with OTIO.
All right, thanks Kylee and thanks Eric. It's really cool to see that come together so quickly and again to sort of show how metadata kind of flow through a brand new pipeline in flexible ways. All right, so we want to thank everyone for coming. Our technical steering committee put a bunch of effort into gathering this stuff together. And we also want to highlight sort of a new thing that just happened, which is OpenTimelineIO was awarded the 8th annual Pipeline Award, Pipeline Tool Award from the Pipeline Conference. So we want to thank them for recognizing OTIO. That was a really special treat to participate in their event last week. And you might be wondering, how can you get involved? You know, this is a community project, and we're really, really excited to have people from all walks of life, whether you're doing this professionally or not, to come and contribute and to work on moving Open Timeline forward. And with that, I think we're going to open it up to questions. So thank you to all of our presenters, and I believe that all the presenters are here. So if you have questions about any of the segments that you saw, or OTIO in general, or future directions or things, feel free to type them into the Q&A. And I believe that we can even promote people to talk on the microphone if you want as well.
So it looks like we have one question from Simran Speller, and he asks, any progress on the annotation front? Haven't heard anything recently.
Yeah, that's a great question. So there is definitely some work happening in the ASWF review and approval working group. Sam Richards, I believe, is sort of championing, sort of gathering the sort of ideas and things for annotations in the sort of review context, with a look towards using OTIO to help sort of carry that around. I think also that the Autodesk folks have a lot of thoughts on that. They presented some thoughts a while ago, but so I would say that the activity, or the active work on that is happening in the ASWF review and approval group, and we can get you a link to that as well. So that would be the place to sort of go about that. We had maybe a month or two ago, we had some folks sort of come to our OTIO bi-weekly meetings to sort of present sort of how that's working. So I think the ahead.io folks came and presented their open annotation project and things. So there's a bunch of different people sort of like all sort of thinking about annotations and how that would work. And I would say that if we can focus all of them together into the review and approval working group, that'll be a good place for that to really come together. All right. More questions? The floor is open, so you can ask anything you want. Let's see, Calvin says, I love the idea of the Hackday. As a student looking to engage with the ASWF project and OTIO specifically, it could be really cool to have a hackathon sort of event to engage with the project with experts and others that are passionate about the project. I think that's a fantastic idea. And I think having just in general an ASWF Hackday would be really, really fun. So yeah, duly noted. I think that would be fantastic. So if anyone else is interested in the same kind of thing, feel free to let us know. We can gather some momentum around that.
So we have a question from Daniel here. Hi, Daniel. Good to see from you. Yeah, so what's the estimated time of the OTIO integration in the Foundry products?
Nigel, I think that's a question for you.
I'll answer that, shall I? Or I might not answer it. It's on the roadmap. It's not going to be in our next release, which is going to beta in about 2 weeks' time. But it is work in progress, and it will be coming in a future release fairly soon.
Cool. Yeah, we're excited to see that integration in lots of different applications, and we've certainly heard some sort of rumors and glimmers of it, of OTIO support in a bunch of different things. I think for the vendors, sometimes it's hard to kind of nail down specifically a schedule on that. They often don't want to promise something until it's actually right shipping. So Nigel, we appreciate your transparency there, and yeah, we're eager to see that as well.
And just to jump on what Josh is saying, like we said this in the presentation, it really helps as customers of these products that you voice your interest in them in the integration. That's what helps move it forward. Thank you.
So we have 2 questions in here about native integration. So one question is there a timeline for seeing native support for OTIO in some of the packages mentioned? I think Nigel addressed the Foundry side of that. Does anyone, I don't know that we've heard a whole lot else from people other than the Autodesk at the moment.
No, I think all we know concretely is that there's a bunch of folks sort of working on that, but I think we don't have sort of release dates or versions or anything like that from any of them that I know of. We do have a wiki page that sort of links to a bunch of other projects that do support OTIO, whether they're commercial or open source or whatever. So we can make sure to follow up with that on the ASWF Slack to remind people about where that is. And that's a great way to sort of discover like what things are out there. Even for applications that don't have the native support, there are sometimes plugins to those applications that add in OTIO support. So for example, Daniel, who answered a question earlier, had worked on a plugin that adds OTIO support to a couple of different applications. So sometimes there's some sort of glue or sort of plugins or something that exists out there that's made by the community.
Okay, and we've got one other here. Native integration with vendors is a great first step to get applications to write OTIO timelines. One challenge studios always run into with native integration is that there's always studio-specific file resolution requirements, metadata handling that needs to be done. How is that being balanced against what will be natively integrated?
That is a great question. So OTIO has a plugin mechanism that we call the media linker, which is specifically for that kind of linking to media. There's a couple of other types of plugins that can happen before and after reading and writing an OTIO. Currently, that's all happening at the Python layer. So when you're doing the conversions with adapters, so that mechanism exists in there, and I think it's sort of an open topic to discuss how that works with the native C++, and what are the sort of the right sort of secure and helpful ways for applications to have plugin mechanisms either managed by OTIO or provide that themselves. So I would say that that's an ongoing work at the C++ layer, but at the Python layer, there's a bunch of plugin things there. So if you just look for OpenTimelineIO media linker, you can find some guidance around that in the documentation.
And that's our time.
All right, thank you, everyone. I think we peaked a little over 100 participants. Please get in touch if you want to know more, and especially if you want to get involved and ask those vendors to add OTIO support. We're looking forward to that. Thank you.
Thanks, everyone.
Thanks to all the speakers.
Thanks very much. Good night.
And thanks ASWF for helping to organize this. We appreciate it.